Morning children, Sai Ram. So today we will continue the same chapter, that is fun with magnets. In this chapter we have studied about the magnets, properties, types of magnets and properties of magnets we have studied. And today we will and in the last lecture I have given you a homework to find out why the north pole this aligned towards the north direction and south pole aligned towards the south direction in a this magnet. So hope you all have studied about this also. First of all, we'll study with this today we'll start with the magnetic compass. So what is a magnetic compass? This is what, as you can see in this figure, this is a magnetic compass, and in the magnetic compass some important things to be consider are this. As you can see here, it is n written here. This is south, this is west, and this is east. So in the magnetic compass directions are given, and as you can see the needles of the compass, and you will observe that only one needle is red in color, and this needle always point towards the north direction. This needle will always point towards the north direction. Wherever you go, this needle will always point towards the north direction. So on finding the north direction or north direction, you will be able to find easily other direction. So it consists of a small needle shaped magnet that moves freely. This is a magnet that moves freely on the pivot. Pivot, as the you can see a bulged part in the center. This is what, this is pivot, and the needle is attracted by Earth's magnetism and align itself along the north-south direction. The north pole of the compass point in the north direction, and it is marked by N, or we can see painted as red. And once you know the north direction, you can easily find the other direction. How? If you are standing facing the north direction, then your back will be towards the south, and east will be on the right hand side and west will be on the left hand side. Means by knowing the one direction only, you can find the other directions also. So this is the magnetic compass. It is used to find the direction. It is a tool that in which a magnet is there in the shape of needle, and that needle always point towards the north direction. So this is about the magnetic compass. So after this we will discuss the earth as a giant magnet. Yes, earth is itself act as a magnet. As we are talking that the north pole or this a freely suspended magnet always aligned towards the north south direction, and the north poles of the magnet point towards the north direction and the south pole towards the south direction. This we have studied that the north poles of the magnet this align towards the north direction, and south pole align towards the south direction. So how they align themselves, why it is so, means why only they left freely, then only they suspend. So this can be explained by assuming that the earth is itself a giant magnet. Earth is also a magnet that is attracting the north and south poles of the magnet. So we can say that there is must be another magnet with its north and south poles in the opposite direction of the freely suspended magnet. Yes or no? Now, with no visible magnet, it is easier to believe that Earth itself behaves like a giant magnet, and the north pole of the Earth is towards the south direction. Now, keep this thing in mind. The magnetic north pole of the Earth is towards the south direction, and the here you can see. I'll show you here. We can say that the magnetic north, it is actual north direction and this is south direction. So we can say the magnetic north pole of the earth is in the south direction. Magnetic north pole will be in the south direction and magnetic south will be in the north direction. So this will be south. So south north of the bar magnet will point towards the south and south of this will point towards the north. We can say that actual north and south are different from or opposite of the magnetic north and south of the earth. Means earth is having, if in actual this is north and this is south, in actual this is north and south, but according to magnetic north and south, this one will be south and this one will be north. So that is opposite of each other. So that's why a magnet aligned towards the north and south direction whenever suspended freely. So we can say that the magnetism of the earth is probably due to the movement of molten iron at the earth's core. As we all know, inside the earth core, we can say iron is there, iron filling is there, molten iron in molten state is present there. So this magnetism of earth is due to the iron inside the earth's core. Now let's study about the preservation of magnets and how we can preserve magnet. What happen will when we'll hammer the magnet. So the magnetic properties of a magnet is lost on whenever we heat magnet, whenever we hammer or hit magnet, or whenever we drop the magnet will lose its properties, means the strength of the magnet will lost. So we can say if a magnet is dropped frequently, hammered or heated, it will lose its magnetism for or get demagnetized. Demagnetized means losing property of magnet, or to lose magnetism and magnetic properties by a magnet is known as demagnetization. When two magnets are placed side by side with like poles adjacent to each other, they lose their properties. Means north and north pole, if you will keep north and north like this, two magnets are there, north and north, and if you will put two magnets like this for a long time, they will get demagnetized. Similarly, south south, they will also get demagnetized. So how to keep magnets? A correct way to store magnets: for this, what we can do, keep two bar magnets in pair in a wooden box with their unlike poles on the same side. Unlike poles on the same side means if you are placing inside a box, this is north and this is south, so this side should be south and north. So this is north south, this is south north. So these are unlike poles on the same side. Separate them by placing a piece of wood in between. Means now here in this diagram you can see these magnets are placed with north and south, and similarly here north and south opposite, and a wooden block is also placed in between them. A wooden block is there, and here on these two sides, what is there? On the two sides you can keep a soft iron bar. These are soft iron bars and they are known as magnetic keepers. Okay, those who stand on gates are called gatekeeper, and so they are standing on the edge of two magnets, so they are magnetic keepers. They are known as magnetic keepers. So here in this horseshoe magnet also you can see this is north pole, south, these two are north pole, and here what is kept? A soft iron is kept, and this soft iron is known as the magnetic keeper. So if we will keep the magnets in this way, they will not get demagnetized easily. So precautions while working with magnets: we cannot use anything freely or without precautions. some precaution should be kept while handling things. So for with working with the magnet, while working with the magnets, you have to keep some points in mind. First of all, that magnets should not be kept close to CDs, credit cards, computers, or televisions, or refrigerators. All these things, all these instruments, what they use magnet. And if you will place magnet near these things or these instruments, they will not work properly. Okay, so they will not work properly. So we should keep away these types of magnet from the electrical appliances, especially the electrical appliances. We should keep the magnets stay away from all these things. So this is all about the magnet and its properties. Hope you all enjoyed the chapter, and go through the chapter, read the chapter, and you will be able to understand all the things. Take care. Sai Ram.